All right. Hello. Welcome back. I think all our levels are good. And yeah. All right. Hi. I'm Agents Ultra. I'm going to be programming and hanging out with you for the next little while on this stream. If you haven't tuned in and watched before, I mostly do stuff in Haskell. Somebody told me once that it was a research language and you can't build real software with it, so I accepted the challenge. And that's what I do. And for the past few sessions, weeks, couple months, I don't know how long it's been. I think we're on like 15 or 16 streams now. We've been building a database client for the TigerBeetle database. TigerBeetle is a financial transactions database, if you don't know. It basically handles financial transactions on like a double entry ledger, credits and debits, that sort of thing. It's kind of small, compact, built with some interesting technology, and doesn't have a Haskell client yet. So I thought it'd be a fun way to learn how the database works, what the developer experience is like using it by building a Haskell client for it. Yeah, so there you go, and that's what we're going to be working on. So I'm going to get my development environment running here. So we just finished up the synchronous client a while ago. Not too long, well, a couple sessions ago. We started working a little bit on the async client. So the async client is what I'm trying to figure out how we're going to design it. I'm not like super sure the best way to do it. I'm thinking start small and simple and we'll build our way up, you know? So the way the sync client works is pretty much how an async client works. The only difference with the sync client is that we just loop until we get the response back, which blocks other code from running, right? At least if you're running on a single thread. Wastes a bunch of time. All right, so pop in here, we go await result. And we check if we have a result yet. If we don't, then we delay the thread and try again. Otherwise, we just return the packet. Pretty straightforward. The only real difference to this and the async client, I think, is going to be that we don't wrap the callback function. We let the user pass their own callback function in. All right, so we don't create our own internally with clients. In the async with client, I think what we're going to do is just that, kind of like the sync client. Now, yeah, let's just go with that. So like we got some state going on here. We're going to start off with just passing around the async client pointer, just the raw client pointer, the raw layer, so that we can get those in the commands. We have our async client T actions. Right, so the with client is going to take an async client T action this time. And then we have our commands as usual. Now, I think what we need to do with the async client T is pass in that callback function that you're going to use to receive the data. Okay. So we're going to call back into your code whenever we get the response back. We're not going to wait, right? And the idea is that you're going to spawn off your threads to handle, or you're going to structure the application however you need, but you're going to be managing getting the responses back and doing whatever you need to do with those. So let's pass a callback function in here and like our configuration. What would that look like? it's going to be, well, I'm going to look at the interface. So completion callback. That's the type of it, yeah. Unit pointer T, 2 packets, 64, and the data, return data, and the size of the return data. I think this is important because we need the one thing I would like to know when I'm using an async client and I call a command is that when I get a response back, I know what command failed. All right, like if I said create accounts, it would be nice if I knew when the response came back that the create accounts command failed, that it ties back to that command. So I'm going to look up the TigerBeetle code and the examples to see what that parameter does again. Let's see some examples. Hey Twitch TD, how's it going? Welcome to the stream. How you doing today? Okay, so in the C code example, at least, provides synchronization context between the callback completion context. Interesting. For each send request, we pass one of a pointer to that in. And it does take a lock on that context. Operating system in 1,000 lines. That sounds cool. Let's check that out. You know, I kind of want to do a project like this at some point on the stream. This would be fun. Something super low level, very, very minimal, but, and basic, but doable, you know? Cool, cool. Well, that's neat. So did you get one, did you build like a whole microkernel for this? Oh, cool. Yeah, that's awesome. Another good one, if you might have already know about this one, but the Kilo editor, text editor, build your own text editor. Yeah, about 1,000 lines of code as well. It's not an operating system. It's a little bit more. But this one's pretty fun too. One interesting one I did too was Nan to Tetris. Right, where you build, in part one, you build the Vermal, or I forget which one they use. You build the chip all the way up. And then in part two of the course, you build a compiler for it. This like computer that you build in the first part. And then I actually built that compiler in Haskell. Yeah, it's supported. What I really like about this course is that they have an online platform and tooling to get you going, which is super, super useful when you need to like really understand the machine code and stuff that you're outputting from your compiler at the different stages, and check that it's correct with regards to the spec. So they give you like a VM and, well, VM tools and stuff, so that you can check what your compiler outputs. You can check it inside the VM tools and stuff, which is pretty nice. You've gone through it also? Cool. Yeah. Nantuchurch is pretty sweet. Kilo is pretty awesome. Little hacker projects. Super great. I think everyone should try those sorts of things every once in a while. Right, so in this version of send request on the C client, they do lock and await completion. Oh yeah? Yeah, it's really fun. Maybe I'll dig that out, my compiler out, and show it on the stream sometime. Yeah, this one looks like a blocking client as well, because it's sleeping on this condition variable, it sounds like. Send request. No. Yeah. Yeah, it submits, calls TB client submit, da da da. On completion function. Context. Okay. Okay, yeah, and the third one is the timestamp and the data and the size data. Okay. So context, I think, used between the callback and the main thread. Right, so I think that parameter is going to be important for the user's callback. So they know they can do that kind of matching. They know they can set up their own context there so they know which commands are what when the responses come in with the callback. So the goal for today, Twitch TD, we're just kind of exploring how to design the async side of this library. We pretty much have the sync side done. And so I'm just trying to find like a good Haskell-y API for the async version, which is going to be very, very similar probably to the sync one. Yeah, and then once that's done, I'll probably cut 1.0 of the library and get it up on Hackage. And yeah, I don't know. Maybe I might actually this week, I might actually do some more streaming tomorrow and Friday. We have hack days at work, and this could be a slightly relevant project for me. So I might stream myself working on it some more in the next couple of days. We'll see. So yeah, just trying to work on the async library and get that going. So our callback is going to have the completion context, and that's a uint pointer, isn't it? On the C side of things. I just had it. Where did I go with that? Yeah, uint pointer. So I think that's what links up the submission of the packet. Because if we go... Okay, so we created an operation, get some data, set the data size. So they pack user data, a reference to the thread context in user data. And then send request with the client, the packet, and the context. So I think maybe this is how we do it. Possibly. But what I'm curious about with this, they don't set the con. Maybe we got to check out how they call it in send request. Just TB client submit. Right, the packet, right? So the packet should have the thing. So I think this is basically what we do in our sync client. Right, we loop until we get it. I don't know what that parameter is really for then. Oh, okay, interesting. There's UN pointer T here, right, and TB init status. A global context. That's used to, I guess maybe that's used as a global thread, like maybe you pass like a thread ID or some kind of ID there so that you know when I send it on thread A, all these replies will come back to me, and in the callback, I can route the data back to thread A when the callback is called, if that makes sense. That seems pretty reasonable-ish. Because you get that past here. I'm guessing it's null if it's not set, because it's a pointer. So, okay. But in this case, they're not using it in this sample, so, because it's all single-threaded. Okay, so in the sync client, we init the client cluster ID address, and we just set the global context, I think 0. Hard code it. And give the callback here. So what? Maybe we should give like a. Do you want to new type it? Maybe I want to new type it. Something like. And that's got to be an unsigned in pointer. We're just going to be, let's just do int for now. All right. And if I throw that in there, then the callback could be thread context. This will be like a TB response. We'll try to wrap a TB response. And you're going to be in some kind of monadic IO context, and we don't really care about the return type. Does that make sense? All right, well, let's start rolling with it and see if we run into what kind of problems we run into. TB result. Okay, I'll get my builder going. Near. on scope. TV response. TV result. I think I meant TV response there. But we're actually probably going to just do unit. I'm going to comment these out for now. It's supposed to be T. Okay. So with client, just sets up the state and runs the reader for the action. We're also going to do a little bit of wrapping up the callback function since we're going to be taking one from the user. We're going to wrap the low-level callback. We're going to wrap the user's callback with our low-level callback so that when they get their callback called, they get the decoded data so they don't have to do the low-level decoding stuff that we do internally. And the same client, like with decode response and such. And the data pointer and all that stuff, they don't have to do any low-level pointer manipulation. Because that's not fun. Well, it is fun, but users of the library don't want to be doing that. They want to be using the library, right, to do it for them. So, let's see. We don't need our tvar IO for this one. We're going to just do that callback stuff. Just like the make completion callback. Except we're going to take the context from that one. I think we need the TV packet pointer. Don't think we need that part. The result data pointer. The result length. That's just like before. We get the response by decoding it just as before. And then, instead of lift IO and writing to the tvar, we're just going to call the user's callback. But we're going to construct the thread context and the TB response to give to them. And hopefully our M lines up with what the make completion callback expects. That's going to be the TB packet. The context here, CTX, is going to be a uint pointer T. I'm going to have to figure out how to do that. something with CTX and TV response. Okay, we don't have that in scope, so let's bring it in. Oh, sorry, peak is from storable. I'll import qualified as raw. The response. So that decode. There. Ah, that's what I was wondering it was going to happen. So this type error here could match type M with IO. Pretty simple error, but kind of hard to see unless you get used to it. Sub call wording band. Okay, now that that's dealt with. So anyways, it's kind of hard to see, but they're basically this callback here, make completion callback, returns explicitly an IO. So we gotta just add the same return type for our user's callback here. Which is good. And then, yeah, all right. Completion context. Oh, yes, this hole here wants to be a function from TB completion context to thread context. That it does. So let's look at that. So in the FFI layer, just a type alias for CU and pointer. Okay. What can I do with a CU int pointer? Can I convert it to an integer? Maybe. Let's go to Hoogle. Okay, wraps a word 64. So at least ours should probably be the same size. We'll import data.word. Okay, but it doesn't give us the constructor, I don't think. Oh, well, maybe it does. But it's not a record function giving us, we have to like unwrap that. That's not scope. We're gonna get it. Twitch TD says, after programming in C/assembly, everything is a 32-bit integer to me. It's such a different world compared to with Haskell. 32 bits? Pretty constrained little systems. I still have 32-bit machines lying around. But yeah. I do have one side project I do for fun that I haven't really done on stream. Worked on stream. But it's all in C as well. For reasons. And it's sometimes magical that we can, like, concatenate through the semigroup instance, like, 2 text strings, and it's not an I/O operation. Oh, iOS 1000 lines was on this 532-bit. Yeah, okay, that makes sense. I was going to say, like, a lot of modern C programs these days are on 64-bit machines, so... But I guess embedded, you know, still rocking the 32 bits in some places. Oh, sorry. You see foreign C types. Okay, and then that's just our constructor now. Cool. Okay, so now we have the callback. Then we can get our results from connecting to the client. We can pattern match on that, just as we do here. Although we're gonna change the right side of things. That probably fit on 1.9 now. Bear. What do we call it? It's not a capital S, it's just a little s. That's better. So we're gonna call it basic client T. Did I do that in sync as well? I didn't. Okay, so just go to that. Async T returns response results. We don't need to. Okay, that's interesting. So we're not using thread context here. Do we actually need the user to pass it in? Oh, wait, init result. Yeah, we do need to use it. Yeah, this. We're just not using it, but we should be using it here. So I need to construct a CU and enter. I guess I can just do it with the constructor. Unwrap this. Call it user context. And Twitch TD, you wonder if the sync can be a special case of async. Just busy waiting for the async call to finish. Yeah, that's essentially what it is. And I think there might be some refactoring we could do here so that we don't have to like maintain two similar-ish looking but modules. All right, this is the top one's the async version. All right, and the bottom one is the sync version. And slightly different monads for the actions. All right, but fairly similar. They're both readers, just over different state. This one has the result bar pointer, which is how we do the critical section for the await call. Which is await result here. And so all of these actions, when you query transfers, for example, submits, and then if we get a client OK from submitting the command, we await the result. What we're doing differently in the async side, I think, I don't know if this is a good idea or not, but seems to be maybe a way to go, is that the user passes in a global thread context and a callback. And that callback we will wrap. All right, so our low-level callback, we'll do all the translate all that stuff, decode the response, and call back the user's callback. Instead of awaiting the result, like we'll just fire this off. All right, so whenever the user's actions get their response back, that callback fires right away. Now, the only thing with this, though, and maybe it's, is that we're still calling with client, right? All that's changing here is that instead of iterating around or waiting in a loop for the response, we just fire this off. So I don't know that this is actually going to work. Like the user's callback is an IO action, so like it could just, maybe we have it set up so that it pipes all of the TB responses into like a channel or something that you can use as a sync in a stream or something. Yeah. Because each of these async client T's, like we're calling in with client here. We're not throwing that off into a thread to execute. So it's not super asyncy. Although maybe I'm just not thinking about it right. I guess, well, I guess it's fine, because like you could ultimately run with client in several different threads, right? And then your callbacks just come back, fly in whenever, right? And then, yeah, you maybe write them to a channel or something like that. That's it's probably fine. Okay. What I'm a little bit concerned about is that as I start writing these out, these commands out, they're going to be super, super similar to the sync client as well. So I think we're going to let the duplication flourish for a little bit before we get into it and see how things change. Now, the type signatures are going to be slightly different because instead of returning the TV response, the create accounts, since in the async side of things, the user is going to get the TV response through the callback. We don't have to return it synchronously, so they just need to return unit. That's going to be one thing that's kind of different between this and the sync client. All right, create account comes from slightly higher level module. I think it's account, yeah. There might be some way of doing that. Yeah, unifying the concept somehow. Okay, create accounts. Because my first instinct is I'm gonna go in here. I'm gonna go, how do I create accounts? And I gotta get the raw pointer. I gotta submit it using the raw stuff. And I get my insync state in order to get my pointer, but it's just gonna be async or async state client pointer. We need, sorry, that's gonna be ask. Record wildcards. And create accounts. Client OK comes from FFI there. All right, so then a wait result is not what we want in the async case. I think that fits just like that. So in the async case, we only have to just like error when we couldn't, when we didn't get a client OK from submission. So if anything, the async client is almost simpler. Okay. Before going into the others, I'm gonna like go to our kitchen sink demo, I think, and I keep saying I think. I'm just gonna go into the kitchen sink demo. I'm gonna set up like a little async. I'm gonna use this async library and see how we do. Right, so now I need to give my thread context. I'll just give it 0 for now. And the callback. And we get the thread context and the result. And all I'm going to do is something like that. Let's leave that comment in because just for testing purposes here. Okay. Now that returns units, so result is just going to be nothing. Okay, so this program should, when we run it, submit this right away, and then at some point in time, we get the callback. But since we're not actually looping here, this is going to shut down right away and probably cause an error in the C library or something like that. So it's not a good program. Let's just test that theory. I'm going to set the database, get it running, and then it's yeah, we don't actually it does we're not even going to see anything. It's just going to like return and done. Right, so we have to run our own thread here then in order to see our result happen at some point in time. I'm just going to import roll.monad run forever. This one is going to loop constantly call async with client and constantly create accounts. It's kind of not what we want either. Yeah, we could just loop at the end. The other thing I could do is set up a TVAR or something like that and await it here. Basically doing what the sync client does, but like as the user of the library, we're gonna await the result. So we write it. Yeah, let's do that. The most proper indeed, Twitch TD. The most proper. And that's how we like to code. We like to code properly. You know? Yes, like fine brandy. Blah 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 blah. T-bar. Control the current STM T-bar, right. It's coming back to me. Alright, results. A new TVAR IO is what I want. Yeah, and so that's our TVAR. We'll put that, let's say, up here just for readability's sake. The completion callback then is going to put onto the TVAR, the result TVAR. False response. Let's put TVAR. Sync flag has it. Atomically up here. Right TVAR. And we're going to write response. And then we will loop for it. And we will read it. And if we've got nothing, it's empty, then we will await again. We'll thread delay. And then we'll await again. Otherwise, we have the results. The yay. And we'll just print yay. Of course, TV response isn't in scope here. That comes from deep within the library. Do we re-export it? No. I feel like maybe that's a point we might want to address in the library. Because this comes from raw response. And my goal here with the library is not to expose anything at the raw layer. have nice API layer stuff for these, but for the sake of expediency, we'll re-export that. Here. And all these as well, probably. That's what might get mad at me. Okay, and this one, we can control concurrent STM for some of the primitives there. And await. Now it doesn't know MMD. Okay, it works. All right, so that seems like the kind of the difference between the sync and async library is just that you're going to write your own event loop for the async library. In the sync library, we just write the event loop for you. So maybe if there's some kind of general way that we could unify the two sides there into one, that'll make maintaining this code easier, so there's less duplication, and that'll be that. So I could see this being pretty straightforward to do. Like, you could, instead of a T-var here, we could have a channel. Callback can write in the channel. It can write in the thread context, and then we can spawn up a bunch of threads that just run async with client in different threads, submitting commands, and then we collect all the responses through the channel, that kind of thing. So I think that's pretty decent. Cool. But I've changed quite a bit of code here. Let's see. Updated main. Changed client. And it's kind of work in progress here. I'm going to split these out into 3 different commits. Yeah. Async example. It looks like it's working. Pretty nifty. I like it. And I think it kind of makes sense that yeah, like you're saying, the sync version is kind of a special case of the async client. Hopefully we can unify that and make it more general, and that'll make things easier to maintain. I don't mind having it in 2 modules right now, but because it's not such a huge library, but it would be nice if I could figure out how to do that. So this commit will add. Alright, Emacs is going to get annoyed with me until I fix this. Burp. Okay, so we're gonna add the async with client implementation. This commit, we're gonna, when applied, this is gonna export TB response from database TigerBeetle client. We should consider a user-facing type to avoid exposing internals. Raw internals. I still want to expose the raw modules in the library, just so that if you want to try your hand at writing your own TigerBeetle client, you can reuse those in the FFI. Or if you just need to, for some reason, dig in to the internals. I like exposing internals. But the main library, I just want to be in like a nice interface. It doesn't have like any pointers or low-level C types in them. Okay, and then app main. Modify. Make it use the async API. I expect most users will probably end up using the async API over the sync one. Sync one is really just for, you know, testing things out, trying it out. But you're really going to build your own event loop probably and use the async API. Okay. So let's get back into the rest of the commands. Oh, get my builder going, that would be nice. Yeah, I need to add these. Yeah, pretty straightforward. Oof, almost painfully easy. but very, very mechanical. So that's kind of feeding into my spidey senses that there's some work we can do to make this code more generic and maintainable. One thing I've learned over the years in programming is not to jump to like making your code super like reusable right away. You definitely can do that in Haskell. Haskell's really good for it. But even in Haskell, yeah, you want to get to working as quickly as possible. And if there's a duplication, let the duplication happen. It's fine, because refactoring in Haskell is a breeze. And often when you see the patterns in the code, especially in the Haskell code, like because substitution works so well in Haskell code, it's really easy to like just go, oh, okay, let's move these terms over here. We can, you know, create a type. We can make this a parametric type parameter, a polymorphic type parameter, that sort of stuff. But if you try to make it super generic up front, you obviously run, maybe not obviously to some of you, but you run into the risk of like creating the wrong abstractions or making your code a little too clever. But if you lean on the type system a lot, it really makes things super nice. That to be async client. Yeah, there we go. Notation and your transfer is not in scope because we need to import it. Sorry, that's gonna be raw dot transfer. Oh, I don't. Oh, naming mistake. I might have made a little inconsistency there. I typed out create transfers here. And in the raw layer, apparently I might have named it create transfer. I did. Should be transfers. Okay, I'll fix that in a different commit. Try and... And then we just gotta change this here. Unit. I think that's all the commands. Added a bunch of commands. Counts. Get account balances. Get account transfers. Three counts. Three transfers. Three transfers. TigerBeetle doesn't have that many commands. Yeah, no, it's pretty small. Yeah, it's a very, very special purpose. It's fairly flexible, but it's still very, very special purpose. And some of that flexibility we're not even exposing fully in this library yet. But I plan to get to it at some point. Because you can add, like in that C example, the C client example, you can add user data into the data packets, which can be pretty useful. But we don't have any way, at least through the API we're exposing, we don't do that yet. But I'd like to find a nice way to do that. So this library is going to support like just the basic functionality for now. Yeah, like yeah, packet user data here. It's passing in a reference to this CTX, which is a custom completion context struct. That's used for some of the critical section checking, I think. Yeah. So like it's got a bunch of custom data in it. Locks. Thread mutexes if it's... Oh, thread mutexes and reply stuff and all that sort of stuff. So, yeah, I want to expose that eventually as well. Okay, the other thing I wanted to fix too was that naming inconsistency. It should be create transfers. And modify router transfer, change create transfer to transfers. Key, sweet. There we go. Async client done. We don't have a ton of time left on the stream, but we got a little bit. Maybe we could talk about the duplication a little bit, see if we can do something about that. I also probably want to move this thread type, context new type. And move it up to client. It's only really used in here, so maybe we want to keep it here. Yeah. Anyway, oh, Twitch TD, yes. I was mentioning this on a couple streams ago. Like, if you're gonna choose Haskell for a programming project, right? Or your company or whatever, why Haskell? Why not something else? More conventional, with bigger, like, not that Haskell is a tiny ecosystem, but a bigger ecosystem of things, like, why? Why would you do it? And I think one of the good reasons is this book. And this reason. Parallel and concurrent programming in Haskell is dope. It is so good. You've got software transactional memory, which we've been using a little bit here. The GHC runtime is really nice. Very, very, very fast, very minimal, and does wonders. So, yeah, if you want to like write highly parallel, highly concurrent programs that are easy to maintain, I would say Haskell's a good choice. So it does a lot of async stuff. There is an async library if you're more used to like certain models of asynchronicity or concurrency, like the promise await kind of thing. That's there. You have green thread multi-parallelism, so you have full threads. I don't know how it would compare to Elixir or Erlang. The Erlang runtime is quite different, and I don't think the GHC runtime has supervisors. So like, you have to catch your own stuff. It'd be interesting to see benchmarks. But yeah, I don't think Haskell's GHC doesn't have like supervisors and stuff. So, but it does have really good, like, another reason why async exceptions are done really well in Haskell, and they're not done very well in most other languages that have multi-threading. So, that's another good reason to pick Haskell. Okay, let's see, what can we do with client? Let's look at them, see what's kind of like similar and what's different. Okay, so async's on the bottom, put sync on top. Okay, first the sync state. The sync case is different. And the callback's obviously different. Because we constructed here, we don't take one as a parameter. So the state is a little bit different between the two. we still run, and the actions are still very, very similar. They both use the same. This is almost exactly the same on both sides. This matches almost exactly the same on both sides, except for in the client OK result, and then in the result type. So this with client returns the result because we're awaiting it synchronously, whereas with client the async case doesn't. It just returns unit because it doesn't need to return anything. Callback gets the return. So could we write sync in terms of this async with client? That might be one approach. Or if I could write a more general with client that takes in the state is some kind of reader that is a... I don't know if I can be polymorphic over the state on a reader, is the only thing. Right, so if I was just to do like a basic client T, for example, right, they could be shared in both cases. I don't think I can make state polymorphic variable. Like if I did S, I'm not sure this would work. Because then I don't think that would be allowed. Maybe I'm wrong though, maybe it would work. Comment that out just so we get this type error. Yeah, no. So we can't like dynamically construct a client with different kinds of state, for one. Although with client has to, when you use the async client, you have to write your own await. If we could, in the async side, make this unit polymorphic. Would that be possible? Yeah, so this is saying here in callback that we don't know, we can't, because like the A here is on the right hand side of this callback all the way over here, so we don't know anything about the A. This unit is supposed to be, or this callback has to be unit. That would compile. Yeah. That's fine. we might be able to do it now, actually, yeah. Right, so this with client, we might be able to make a sync client version by doing basically what we did in main, just lifting await result up into our syncs with client version. And then we can have all of the commands. We might be able to make all the commands a little bit more generic so that they can be over this monad, because they all are very, very similar, except for the client, what to do with the client OK. That's the only part that's a little bit different. Wow. Let's see. I don't know how you couldn't. Because in the sync case, it returns await result here. Yeah, we don't want to make the commands have to take... Like, we don't want to have the commands take this as a parameter. So that would look like, if we did do that, let's imagine that for a sec. That's a possibility. Like we can make an IOA. Something like that, and then we'd basically pass in, or we can re-export, say lookup accounts to be like an internal one, and we could have like that. And the type would be an IOM. TB response. That wouldn't be IOA, it would be IO unit. It's match. Yeah. Right, and then in the async case, this would be... So this would be like sync lookup accounts. Then async lookup accounts would just be same thing, type-wise, except async. And something like that. Then you could parameterize over it and then abstract away the things when you export from the module. And that way we'd only have one set of these commands between the two, and then we can just, in the individual async and sync modules, you can just do it like that. That would be one possibility, except I gotta get this to match up. So these... Yeah, the M's here aren't lining up in sync look accounts. So it thinks they're potentially two different monad IO M's. Doing something silly here. That wouldn't work. That's not in scope. Yeah, I'd have to futz around with that a little bit, see if I can't get that to line up. Or it is a little more explicitly. All right, so what it's saying here is that the monad IO M that we get in this binding, this type level binding here for sync lookup accounts, it doesn't know that this is the same M used in lookup accounts here for this. So, but anyways, that might be one area. So I'm gonna get rid of that code. We'll revisit this maybe next week unless I solve it before then. And then we'll get to publishing the package, I guess, and cleaning things up and adding documentation and all that good stuff. Or maybe we'll start a new project and I'll take the rest of that offline. Yeah, let's get rid of those. No. On stage those. Okay. Let's push that up. Okay, so if this is your first time tuning in, welcome. Thank you for watching. All the code you've seen here tonight is for the Haskell TigerBeetle client, TigerBeetle HS. I'm Agent Ultra. It's been a pleasure. I'm Agent Ultra on GitHub as well, where this repository for this project lives, TigerBeetle-HS. If you want to follow along and all that, give us a star. You know, or contribute. I'm open to getting contributors. If you end up using the library and, you know, have some fixes you want to submit, please, it'd be great. It'll be awesome. and we can make cool things happen. So also check out the link above my head. We got the site back up. It's been up for a little while now. Declarative.tv. It's got other streamers who are doing things in languages like Erlang as well as Haskell and many others. And there's a link to a Discord server there where there's a channel for this stream. So if you're watching on YouTube and watching async, or you think of something that you wanted to ask but couldn't think of it on stream, do it there. I'm always hanging out on that server, and so are lots of other folks. Also, I'm on the Fediverse. I'm on Mastodon on the types.pl server. You can follow me there, Agent Ultra, or my website, agentultra.com. All of those have links to my YouTube where I back up the VODs for the stream, GitHub, everything else, and all that good stuff. So thanks again for watching and hanging out with me. May all your monads be free and your types always check. I do these streams once a week on Wednesdays. So like and subscribe, follow here on Twitch. You'll get notified when I go online. And happy hacking out there. See you soon.